let's quickly look at this electricity question on the EMF of a cell. The question reads, a cell can supply current of 0.8 ampere and 0.4 ampere through a 2 ohm and a 5 ohm resistors respectively. Now the question here is calculate the internal resistance of the cell. And in this place, our question is asking us to find small r. So let's go over the question again. Solution. Observe something. We're given two currents and we're given two resistors. Now if you've studied EMF of a cell, you understand something. We will call this our first current I1. Capital I1 is equals to what? 0.8 ampere. The second current will be capital I2 equals what? 0.4 ampere. And not just that, they said it supplies this current. The cell supplies this current. Now when a 2 ohm resistor and a 5 ohm resistor respectively was connected to it. So this first one, because they said respectively, okay, it means that this current is because of this resistor. This second current is because of this second resistor. So which is our capital R1? It is what? 2 ohm. And which is our capital R2? It is what? 5 ohm. Now why are they in capital letter and this one is in small letter? Are they not all resistance? Now this capital R are the external resistors that are connected to the cell. Why this small r is the internal resistance of the cell itself. So inside the cell there is a resistance to the flow of current. Outside the cell, because of the resistor that is connected to the cell outside, from outside, there is a resistance that is offered to the flow of current outside. Within, a resistance represented by small r. Outside, resistors represented by what? Big R. I hope that is clear. So when the question now said calculate the internal resistance of the what? Did it say of the resistor? No. It said of the cell itself. And that is given by small r. And in this case, we don't know the value for it. So how do we now work this out? We know our I1 when the R1 is 2 ohm. We know our I2 when the R2 is what? 5 ohm. And we are asked to find internal resistance. Now if you studied EMF of a cell, the first and general formula we use is EMF equals I in bracket capital R plus what? Small r. You need me not to emphasize the fact that this capital R is the resistor that was connected to the cell. The resistance of the resistor. While this small r is the resistance of the cell itself. While I here is the current. E here is what? EMF. This is the first formula to use. Now I think it kind of aligns with what we're given. We have I's, we have big arrows, and our arrow, small arrow is unknown. Now how do we now form a comparison between when the current was I1 and when the current was I2? How do we now form a comparison? Draw a relationship between these two scenarios. Now take note, for EMF of a cell, no matter how you alter the resistors attached, and because of that alter the current, there are two things that will never change. Even if you change the resistors and that will affect the current, there are two things that will not change. The EMF of the cell itself will never change, and the internal resistance of the cell itself will never change. And that's why the question was asking you to find internal resistance. Because if it was going to change when you interchange resistors, when you bring a 2 ohm resistor and you now remove it and put a 5 ohm resistor, if the internal resistance have changed, you would have seen something like calculate the internal resistance when the 5 ohm resistor was connected. I hope you get that. So it means that internal resistance will never change and EMF of the cell will never change. And if that is true, observe something. The EMF that will never change is on one side. So we cannot say that this will remain constant. If EMF will remain constant, this as a whole will remain constant. So we'll not do something like this. Watch out. I1. So all the one with ones will go to this side. All the one with twos will go to this side. But we'll be writing it using this very guideline. I1 in brackets, R1 plus small r. Now why did I not add 1? Because I just finished telling you that the internal resistance alongside the EMF will not change. So I will not add any 1. I hope that is clear. Then close the bracket. It will be equals to, we repeat this thing for the 2's. We will now say I2 in brackets. What do you have here? R2 plus like I said, it will just be what? Small arrow. There's no need to add 2 because internal resistance will not change. So guys, you have succeeded in writing out the formula we'll be using to solve this question. And it's that easy, it's not difficult. So watch out, what do we do from here? Do we have a value for I1? Yes. So we'll put it here. 0.8. They said it's 0.8 if you observe. In bracket, what's our value for R1? They said it's 2 ohms. So we'll say 2 plus our value for arrow, small arrow. We don't know it yet, so we'll leave it as that. Are we together? Equals to our value for I2 is what? 0.4. In bracket, our value for arrow 2 is what? 5 plus our value for small arrow. That is what we are looking for. So we are making good progress, okay? So what do we do from here? Let's open this bracket. There are many ways I can solve it from here. But let's just be basic. Let's expand. Open the bracket. 0.8 times 2 is 1.6 plus 0.8 times arrow is 0.8 arrow. I hope we are still together. Equals to 0.4 times 5 is exactly 2 plus 0.4 times arrow is 0.4 arrow. So guys, we are also making good progress here. Now watch out, we can do something. The ones without arrow we go to one side. The ones without arrow we come to one side. So let's do something like that. What is the one with arrow here? You have 0.8 arrow. Let's bring the one with arrow from this side. It crosses the sign, the equality sign, and when it lands, it will become minus what? 0.4 arrow. Now what is here without arrow? You have 2. When this guy without arrow, 1.6, crosses the sign and lands behind the 2, it will become what? Minus 1.6, minus 1.6. So we are making good progress. If you do this subtraction, you will have what they call 0.4 arrow. It will not be equal to, let's do that subtraction together. 2 minus 1.6 gives us 0.4. 0.4. Okay? And mind you, we are absolute for what? Arrow, not 0.4 arrow. So what do we do from here? We are going to be dividing both sides by what is attached to the arrow itself. And what is that? 0.4. So we say over 0.4 over 0.4. And watch out what will simply happen here. 0.4 we cancel 0.4. So we can now come here and write arrow will be equals to what? What do we have on this side? We have 0.4 over 0.4. And we now say our small arrow, which stands for internal resistance. Internal resistance will now be equals to what? Exactly 1. 1 what? Ohms. So we are saying therefore that the internal resistance of the cell which does not change alongside the EMF is 1 ohms.